So, do you see my screen, Lucas? Is everything fine?
See your screen. Looks good.
Great. Yeah, so let's start. And today I will present the topic related to the probably newest Sitecore components and technologies, which is JSS SXA Rendering Host. That's all is hosted in Azure Kubernetes. And so let's start with some introduction of myself. And so I have more than 11 experience of programming experience, and 10 of them I've been working with Sitecore. And since 2012, I worked for Brimit, and I'm currently Sitecore Technology MVP for 4 last years, and I'm located in Minsk. So, if you
Before you move on, there's someone is asking if you could move your microphone a bit closer.
Is it better now?
Yeah, it's much better. Thank you.
Cool. So, and a few words about the presentation and about so what I will speak about. So this is our client. So we developed the website, the corporate website, for one of the Sitecore partner, which is decided to stay unrecognized. So this is not really big site. And the initial requirement of our client was like use the SXA. So, but after some investigation and estimation, we provided a new vision how we can build it, and we suggested to use the new technologies that we have never worked with. So, and our client have not also worked with that technologies, but together we decided that we can try it. And yeah, so this is, as it is Sitecore partner, so they don't have any limits in the Sitecore licensing perspective. So we decided to try. So, and finally we built the requirements, which is the site should be built in Sitecore for sure. So that should be a headless architecture. The front-end part should be built on a rendering host, and against clients still wanted to have some advantages of SXA, and we agreed to use SXA on the project as well. And all the things should be deployed in Kubernetes. And in our case, it is an Azure Kubernetes Services, or AKS shortly. And here we go. So this is my third JSS related topic, since it was announced by Sitecore for a few years. And during this time, the JSS term has undergone changes. And so initially, it was presented by Sitecore as a toolkit for JavaScript developers, allowing to build full-fledged customer solutions like single-page applications, web apps, websites, and using modern JavaScript libraries and frameworks like Angular, React, and so currently Vue.js is also available, and be completely unplugged from Sitecore. And in the same time, the JSS term consolidated the tools and APIs such as layout service, dictionary service, GraphQL, etc. And it is still true, but in Sitecore 10, the composition of things was changed. So, and finally, we got the diagram that we currently can see on your screen, and where we can see that Sitecore connected all JSS-related services in a separate module called Sitecore Headless Services. This module, which previously was known as a Sitecore JavaScript Services Server and was provided as a Sitecore package in terms of JSS, this services provide the server-side APIs and components which are required for ASP.NET Core Rendering SDK and for JavaScript Rendering SDK as well. So uh, we also can see that Sitecore Experience Accelerator on its latest version also uses layout service, but it is provided with separate package, so you don't really need to install Sitecore headless services in terms of using SXA, but they both use the same APIs. So in headless system, in general, don't uh, don't say about the Sitecore specifically. So the front end and back end are separate infrastructures that communicate using endpoints, and the rendering host, and which is a front end, and the Sitecore instance also have different data domains. So the front end contains your website code. It contains static resources and the front end responsible for the rendering. And from the backend point of view, it contains your content items and its management. And yeah, where author can manage the content. So this is we understand it as a backend. But talking about Sitecore specifically, we can say that backend also contains a custom code of Sitecore integrations. So integration with some third-party tools, third-party systems, it is also part of backend development. It contains Sitecore customizations, and it is also responsible for data indexing. So I don't think that's the full list of backend activities and responsibilities, but that's probably the main one. And then when we speak about the Sitecore JSS, we always, so at least me, always think about the JavaScript frameworks that we use to build our websites. So when I hear the JSS, I think about React, think about Angular, Vue.js, so at least just because I've already done maybe 3-4 projects on JSS, but all of them was done using React, and some of them was based on the Vue.js. So, but when we started working on the current project, I noticed that Sitecore also has the Sitecore headless development term, which was really new for me until I was started working with that. So Sitecore headless development splits a Sitecore project up into a Sitecore instance and a separate rendering host. So, and Sitecore headless development, it's not really a tool. So this is probably an approach or a flow how to build headless solutions using Sitecore headless services and rendering host specifically. So Sitecore headless development is based on the rendering host frontend and Sitecore instance backend. This decoupling of logic domains makes a Sitecore solution easy to develop, maintain, scale, and upgrade. Headless systems deliver web pages to visitors differently than coupled system, where the backend and frontend are combined. Sitecore headless development functions in the following way: the rendering host, uh, which is here and which represent our website itself from the visitor point of view, and the rendering host translates a visitor request to the content item in Sitecore instance. The Sitecore instance using Sitecore headless services returns the content item and associated presentation details and so on to the rendering host. The rendering host render the content item for the visitor. And so also on the current diagram, you can see the workstation, which is represent like a development laptop machine, so development workstation. So we can see that developer use still Visual Studio. There's nothing new. You and the it developer write a code based on the ASP.NET Rendering SDK, which provides some clients for the layout service. So the scenes that communicate with the layout service, it also provides a rendering engine, and so this is like a boilerplate that you can use to initiate your project from the beginning. So it will include some basic stuff. So then the Sitecore CLI is also um, important part of the rendering host solutions. Uh, so maybe it is not necessary, but for our project we use the Sitecore serialization stuff, which is really require to use Sitecore CLI. And so to allow using your Sitecore CLI, you have to install Sitecore Management Service on for your solution. Um, so this is kind of also a new term for me, but finally it is. If you uh, wanted to install Sitecore Management Service in your Sitecore, you just need to search for Sitecore CLI package, which is available for download in Sitecore development portal. So, and here the Sitecore Launchpad, that is pretty standard thing that all of us use to access Sitecore, and the content authors works with that in the same way as with the standard solution. So, looking at the rendering host in more details, we can see that rendering host functions in the following way. The visitor sends a request to the web server, which activates the rendering host web application. The layout service client, which is part of ASP.NET Rendering SDK, fetches the relevant content and presentation data, the model data, let's say, from the Sitecore headless services. So we saw that on the previous diagram. And the layout service client passes the data model to the rendering engine, which is also part of the SDK. And the render engine renders the data model and your code and static resources into the final response and return it to the visitor. One more thing that I also mentioned already, that we are using the SXA. So we're still working on this project, and this project is still not in the production. So that's because I'm saying that we are currently working, we are using. So, and there is no fully supported by rendering host. So, but it is still the same as for the JSS itself. So you can use all advantages of SXA, like multi-site designs, partial designs, and you can manage it you can create the modules and build it in the same way as on the standard SXA solution, but you cannot use the components provided by SXA. You cannot use a drag and drop functionality, which is also provided by SXA for the MVC projects. So, but it is still good. So because some things already done by SXA, and you don't need to think about how to manage your sites, and so it makes something easy. So let's go further, and now I'm going to explain our development and deployment process. So, and this diagram, so basically this is like a popular diagram, so they was shown a few times in different presentations, but we still use the same process. And when developers work locally, they just put some code in the repository, commit it, or usually uh, create commit and create the pull request, which is trigger the build pipeline, build continuous integration pipeline. So during the build, all our custom code is compiled on top of default the default images, base images provided by Sitecore. So this is a Docker images, uh, which is finally compiled with the custom code, and those final images pushed in the container registry, which is also a part of Azure. And when the build is ready, the release or continuous delivery is triggered. It can be triggered, or it probably can be run manually. And when it is run, the release pipeline just say Azure Kubernetes to update its nodes, pods probably. So, and when Azure Kubernetes get this receive this command and the specifications, it requests the latest images from the content registry, which is already have a new code which we push on the build stage, and it is update itself and provide a new functionality for the users. So this is how it works in Kubernetes. During the demo, I will probably explain a bit more how we can configure and how we deploy it. I will show you pipelines that we use for deployments, and now I want just explain a bit how the Azure Kubernetes architecture looks like. So right now we have only one environment, uh, which is UIT or acceptance environment that we provided for our client, where the client can already can put the content already, and this is we consider that environment as a non-production, and but as it was first experience for us to build Kubernetes projects or Kubernetes environments and deploy projects there, we decided to build our UIT environment exactly in the same way as we are going to deploy our production. So this almost the same. Only one thing that is different that we are not mm, using the external SQL Server, Solr, and Redis. So we still run it on the Kubernetes, which is allowed for non-production environment, but for the production, the services should be like external services. So in general, we can see like our Azure portal. In Azure portal, we create the resource group, which usually associated with the project client and so on, and includes all stuff related for the environment per client or some other reason. So that's pretty general stuff for the Azure. Then when we are going to deploy something to the Kubernetes, we need to create the cluster. And cluster already um, is associated with some region like Europe, West Europe, and USA, Canada. So that's different locations that Azure provide for the clusters where it can be located, and it really depends where your business is. So, and inside of Kubernetes cluster, we have a node. The node is like a server, and there is two different type of nodes that you can utilize. So basically, this is a Linux node which is required for every cluster, and use like a system node, but you still available to install something on this node. And basically, if you will set up your environment, go through the documentation, and there are mentioned that you can utilize the master or system node for some stuff like Solar Redis. So it is installed there automatically, but the default size of node which you defined and which is depends a cost that you will pay for this node is not really enough for build, at least to build the XP1 topology. So I spent maybe about 1 week or more, maybe 2 weeks to set up the environment in Kubernetes, but mainly my mistakes and my issues was related with the lack of resources that we initially buy in. So the size of nodes was not enough to run the XP1 topology, just because the size recommended by Sitecore for non-production environments is probably suited to the XM, probably XM topology of Sitecore. So, but we decided to set up the same topology as we are going to set up on the production, and that was our mistake, but not maybe mistake. It was our uh, main issue, main reason of all our issues. So, but finally we scale up our Linux node and everything installed without any errors there. And the same issue was with the Windows node. The Windows node is just a type. Usually it is require some name, so of the node. And on the Windows node, all our Sitecore related stuff is hosted. So and all piece of data, so all the roles, CMCD ID is in terms of Kubernetes is called as the pod. Uh, the pod is like a smallest uh, piece of infrastructure in Kubernetes. So all these things, all these pods communicate between each other. Uh, if if look in the infrastructure in more details, all pods is wrapped with the service, which is used to communicate between the pods. And also, really important things here is Nginx ingress controller, which is used uh, as a load balancer. Probably it's on, but it is not really a load balancer. That's like a router, which route the traffic to the correct server, to the corresponding server that you request, usually based on the domains. Uh, it is configured, and I will show you how. But it is really required only for the servers that should be available outside. Yeah, so this is about our non-production infrastructure. And if we will look at the production one, there is not really a lot of differences. Only one thing, that we don't have anything inside of Linux node, but we still have to pay for them. So this is a system one, and yeah, you cannot remove it, but you have to buy them. And all other nodes, another Windows node still have the same pods inside, and we can see that for the production, we have to create accounts and configure it for the Solar, which usually search stacks, some Redis provider, and for the databases, it is recommended to use SQL Elastic Spools. And everything else is the same. And in terms of scalability, it is really makes sense to create probably two CD servers inside of the same node. And usually it is another node or even another cluster creates in separate region, and each cluster will have the Nginx controller inside, and on top of those clusters, the Azure Traffic Manager is utilized to route traffic between to balance and route traffic. Between two different clusters in different regions. So, and now it is in demo time, and I will try to show you how we built our project. Just a second. I'm going to. Yeah, so this is our project, which is built in terms, so according to Helix principles. And so the first question from our client was how it will looks in terms of rendering host and Helix. So how how it is stored in Sitecore or in Visual Studio in our solution. And basically, we can see that it is very similar, but we have the separation between platform and rendering. The platform is a standard .NET framework project, web projects, and this is this prints this so as usual in VC project. And we have a .NET Core app, .NET Core library created for the each feature, and it is called like it and it has a postfix called rendering. So speaking about our project, and we basically create content resolvers for our components and put them to the platform layer, and the implementation of components are placed in the rendering. So that's probably understandable. So then we have to create a model for each component, and the models is pretty simple, but we still need to use the predefined types of fields, for example, which is provided by Sitecore SDK, rendering SDK, and it allows us to use experience editor. So we still can use like string here, but it will works only with the string values that comes from the Sitecore, from the layout service, and it will not be work with experience editor. So probably can find a bit more examples. We have a rich text, we have an image field, we can extend the default types with the custom one. It's still possible, but it is usually required when we use maybe some custom fields and some additional data uh, on top of the value, and edit and editing stuff comes from the layout service for the field. Um, there is also an ability, for example, to create to create to receive the parameters, the rendering parameters from the Sitecore, and there is attribute that we have to use. We have to use for that, and it is called like Sitecore component property, but uh, the understand of this attribute is not really clear. So using this attribute, I was expecting to use to get any property from the serialized item from the component, but it just allow us to get properties ID and just a few additional fields, just because it used the reflection to get a property from the object that comes from the Sitecore. So, but we can use it for the parameters at least. If we need to access some rendering parameters. So when we prepare our model, yeah, so also we can map another type of items to the another. So we have another model that we want to, and we get the list of these items from the layout service, and we can also map it using the default Sitecore stuff. So when we're ready, when we have a model, then we don't need to do anything else. Sitecore do that themselves, so himself, and we just need to implement our view, and so we still can access the Sitecore context in track. Is it editing mode and not or not? So if we want to access our experience editor, we need to use the predefined tags, which is, we have a date, we have an image, link, number, placeholder, and text. So that's all what we can use, and which is supported by experience editor. You can always render any data as you want, but don't expect it will be supported by experience editor and editable inside in experience editor. So from another point of view, that looks pretty dissimilar with the MVC. The syntax is a bit different, but views looks, it's, if not the same, but very similar. So this is in case when you don't need to apply any logic to data that comes from the Sitecore. You just create a model, you create a view, and the model will be mapped to the view is automatically. So, but sometimes uh, we need to customize something. We need to prepare data to be rendered correctly. So, and in this case, we have another option, which is view components. This is a default ASP.NET core stuff, and it is utilized. It can be used like as a controller, but it is not really controller. It's just a handler for the model that comes uh, that will be posted to the view. We have invoke async method here, and we can prepare any data that we want to send to the view, and it allows to be a bit flexible. So speaking about the concept that we use for our rendering host, we decided to don't use Sitecore for search. I mean, if we have some data in the index, in the Solar index, we decided to don't send the request to the Sitecore when Sitecore will send the request to the in this when yeah then Sitecore send the request to the Solar, get results from there and send it again to the rendering host. So it seems like one extra step here, and we decided to implement our own layer which communicate with Solar directly. So we use the same tool, which is SolarNet, and build our requests and queries to the Solar from the rendering host, and don't use Sitecore in this chain at all. Um, the same with some integrations. Like we have a small integration with the Instagram, and so we don't really need Sitecore here. We don't store this data in Sitecore. We just render a few latest posts from the Instagram. So, and we have implemented this integration on the .NET Core part, not from on the Sitecore. Uh, yep. So that's how we have approached that. Some partial renderings, so you can separate some data from the main view to the partial views and iterate them. So that's pretty similar how the MVC works. And locally, we works with Docker, and I don't know how many of you works with Docker, but initially it was really tricky for me to start working with that. So, but finally, I found it as a great stuff when I just can move my project from one laptop to another, for example, and just in a few clicks I can run the project. So, but if you was working with the Docker, you know that the Docker Compose executes some a bit long time. So while it builds all images, it can take if if every base image is already downloaded, the build takes just around 50 minutes to run the project with the latest changes. But the Sitecore and the community provided the example for the project, and it is also help us in development point of view because we have the environment platform project which we can build, and it deploys the project the changes in the Docker faster. You don't really need to rebuild to run a build of Docker, build images, and update your Docker images every time. You just need to build a project. The same way is utilized for the rendering, but in this case we have like a root rendering project which accumulate all rendering host stuff. Let's say rendering host stuff, but it is just .NET libraries, .NET Core libraries, and uh, deploy them to the Docker. So just forgot to mention that when you add some views, then you have to register them in the extensions method. For example, add feature-based content which accumulate all views, which map the model type to the view by view name. And in the main project, in the in the startup, you have to execute these static methods and static helpers to get Sitecore known about these components you have. So And when you build, or even when you change any view or any code on your rendering side, the voucher, which is run with the Docker images, is track your changes and deploy it immediately. You don't really need to build the rendering host at all. And so we have a project which is rendering host, and here we have defined our layout and another default Sitecore stuff related to the presentation. So now a few things from the solution point of view, and this is how our project looks in the file system. And here we can see that we have a list of Docker Compose files. So at least Docker Compose and Docker Compose override is used locally to build the local images. But locally we utilize the XM topology. But in our production and our UAT environments, we use the XP1 topology. And to be able to build the images for our UAT, we need to have additional files, additional Docker Compose files. And here, a few different ways how it works locally and on Kubernetes. So because, for example, locally, oh, sorry. Just yeah, for example, SQL Server. Locally, we use the parent image, which is base image provided by Sitecore, which is Sitecore XP0 MSSQL. So, and it works fine locally just because this image contains the SQL Server itself. But when we run it in the Kubernetes, the SQL Server itself is run in separate way as a separate node or really pod, and we don't really need to upload and build and use the SQL Server provided with this base package. But it is always, and everything says that we need to build our custom images on top of the Sitecore provided. But what does it mean exactly? I've not found, and I spent a lot of time to understand. But finally, we will have a look in the same um, in the same, not really here, yeah, in the same way. So for example, we need to upload to extend our MSSQL with some data associated with SXA or with Java, JSS or PowerShell script or PowerShell module, and we still need it to upload to the database. And the same for the yeah, we can look at this example. So the same for the Solr, we need to add additional indexes for SXA, and we need to use the init base model, init base image to get it working on the Kubernetes, because this init image does not contain anything else. It just contains the additional data and doesn't contain the Solr itself. So it is why I have a separate Docker Compose. I just separated in terms of development, in terms of deployment, and I compose these images separately. So, and now we have the Kubernetes folder here, which is explain our pods in Sitecore. Oh, in Kubernetes, sorry. And this is YAML files with some definition of pod, or really it is called like a deployment in terms of Kubernetes. And when we add a deployment to the Kubernetes, it is executed there and create a pod. And for example, when we call it CD, uh, the CD deployment will be created, and CD pod, which will represent the CD server, will be created. So, and when you just remove the pod using, for example, PowerShell from the Kubernetes, the deployment, which is still there, will automatically recreate your pod. So, which means that if something happened with your CD server in Kubernetes, it is shut down, it is broken with some issues, I don't know. So anything when become when make it unworking and unhealthy, the Kubernetes will recreate this pod against until it will not become working. Maybe it will become working only with some additional deployment anyway. It is sometimes very useful to keep it stable. So this is, you can see, so speaking about the Kubernetes, this is a very useful document provided by Sitecore. And if you are going to deploy something to the Kubernetes, you really have to read it and follow the document, and everything should be fine. And there is some just a few errors that I mentioned in documentation, and one of them is related to the deploying ingress controller. Just maybe it will be useful for somebody. And so the first step that you need to run is to add a repository, which is, according to documentation, is called like a stable. But the next step, which should use this repository to download the ingress controller, already tried to use another repository which is called nginx ingress. So in this way, if you run the first command and then run the second one, so you will be you will get an error. Will get error saying that repository is not found. Yeah, it's really simple, and maybe it is obvious issue for somebody who has already worked with the Kubernetes and know how it works, how Helm works. But for me, I spent maybe a few hours to understand why I don't have the repository when I've added on the previous step. So, and another things when you set up the non-prod environment. Uh, so here, uh, the almost first step saying that you need to have SQL Server, Solar Cloud, and Redis already installed on as a separate services. But for non-production, you can go to the section which explain how to run these services, these features, and these tools in Kubernetes, uh, and take into account that it is first step. But when you will try to run this non-production services according to the documentation, you will get errors just because those services use some secrets, but the secret is not deployed to the Kubernetes. So, but even this step is first, and it point you to the another section which you will try to execute. You will get errors because before run the commands provided in this section, you have to execute the command which will upload the secrets, which is like uh, passwords and users for databases, Sitecore admin password, and everything, every everything which is related like to the Sitecore configuration. So you have to deploy secrets first, and then you can run external services on Kubernetes. So external services means that it is SQL, Redis, and Solar, and in my case, it is also .NET SDK, which is deployed separately. And then there is also one folder which is init, and this folder contains the definition for initial data, like I'm saying before, we need to add like additional data related to the SXA, but uh, I built the package, the custom image, which include the SXA and Headless services in the same image. And also, this is not a deployment, which I explained in the previously. This is a job, and job uh, also create the pod, but usually it is used to make some changes and add something that to extend something that is already deployed on the Kubernetes. Uh, yep, and where is my plan? Uh-huh. One more thing that maybe makes sense to mention about the SXA, that when you utilize the JSS and SXA together, SXA provides the custom configuration for the JSS stuff, and when this configuration is used, the rendering that has uh, spaces in their name will not be found by JSS. That's something like Sitecore bug. So I just will show, for example. So all these renderings shouldn't have the spaces in the name. So otherwise, the experience editor won't work. So that's what I was mentioned during working on the project. Uh, just a second. Let me. Maybe I missed something. Yeah, probably that's all what I'm going to show you. Maybe I can. There is, yeah, maybe just a few more minutes, and I will finish with that presentation. This is our CI pipelines, which is very simple. We just run Docker Compose command from the Azure, and result of execution of this step will be images built, which is built and put to the artifacts, and then we just push these images to the registry, to the Azure registry, where we store all our custom images, and then according to the diagram that I show during the presentation, so those images will be uploaded by Kubernetes to update the code base. So then we put Sitecore items, and which is serialized items, to the final assets of the build, copy the Kubernetes stuff, and just publish the artifacts. So, but the build process is a bit long, so it takes around 20, maybe 25 minutes. But when we run a deployment, continuous delivery, I will show you a few steps here. Nothing unexpected and interesting here. We just install the kube control module, and which is allow us to work with the Kubernetes. Replace the tokens inside of tokens, Kubernetes tokens. And for example, if you look at the secrets, we can see that it does not contain the values itself. It just contains the tokens, and we replace the tokens with the values stored in the library, variables library, and do apply secrets just because we maybe change the values for the secrets, and if you want to allow Kubernetes to get these new values in the secrets, we have to upload it there, and then we just say for the Kubernetes to set a new image for the pod, and it run the process, and but even though you run the deployment, the site still available because the new pod, new CD pod or new ID pod is created, and during this creation the old pod still working, and only when the new one is available and healthy, the old so the traffic will be routed to the newly created pod and old pod will be removed. So we just update 3 pods. We don't need to deploy anything else here. Oh, 4, sorry. We need to deploy the rendering host as well. And at the end of deployment, we just run the serialization in publish. So we utilize the Sitecore content serialization using the CLI, and we just push latest changes during the PowerShell. So, and once the old CM server pod, let's say role is available until the new one is uploading and running, still running, we still can run the serialization because the old one is available. So that's also useful. You don't need to wait until deployment of CM server will be finished to run serialization. You can do that in parallel. And yeah, so and maybe last thing, this is how the work with Kubernetes happens. That's main tool that you use to work with Kubernetes, and main util that you use is kubectl, kubectl. And for example, now we can see the list of pods, and we can see that they run in the separate nodes here, and they have each of them have the separate IDs, and yeah, that's kind of get the deployment, for example. So this is a deployment that come on, that I was talking about. So, and if I just remove one of those guys, the deployment which is here will be automatically recreate the pod again. So the Kubernetes stuff is really huge huge topic to speak about, so it probably no makes sense to look at it deeper. But yeah, that's a bit difficult. It is difficult at least because it is I don't have enough knowledge about the Kubernetes, and for me the first time when I started working with Kubernetes was really difficult time, but finally it works fine, and we are happy with that. And what I can say to the in the conclusion, and so I don't know how many of you works with the JSS, but I guess some of you worked already, and if even if you are not, you may have heard that work with the work that is available for the backend developers in terms of JSS projects is limited, and sometimes it's routine. You don't you just create a renderings, content resolvers, and maybe sometimes you work on the integrations and customizations, but you don't work with the presentation. And sometimes in the JSS project, the front-end guys have usually have much more work, much more interesting work than backend developers. But in this project, our developers, backend developers, they happy again. So they work with .NET Core, which is popular now. They work with the views. So, and the scenes becomes as it was previously. And yeah, so that's interesting project. I hope we will utilize it in the future as well. So we're happy with that. And yeah, that's all. Thank you for attention. And I would like to answer any questions you have, guys.
All right, thank you, Artsem. It's really interesting. So far we've got one question from Tomek. So how the cost of AKS compares to Sitecore on Azure Pass? If I want to achieve the same level of performance for the same Sitecore topology.
Right now, we just have one environment, which is UAT. So that's a bit difficult to compare the costs. But let's say uh, we have run the XP1 topology inside in Kubernetes. So comparing with like a PaaS or maybe just a standard virtual machines, so that's at least a few servers required for the XP1 topology to run it in the not to run it not in the Kubernetes, but in our Kubernetes, uh, we use just one cluster and we pay. Uh, so let me a bit remember that. So we pay around maybe $300-400 per month. So I can say even this is a UIT environment, it is not a lot. So it, that's cheaper than to pay for PaaS or maybe infrastructure as a service.
Right, thank you. I hope it answered your question, Tomek. Uh, all right, I don't see any other questions. So if you have any questions, you can always, I guess, contact Artsem, right, on Twitter, on Slack, or any other contact data you see right now. Um, yeah, so thank you, Artsem, once again.